everyone. Today we are going to understand pipeline, MIPS architecture and learn how to analyze hazards that occur inside pipeline. First we have to know what is pipeline. Pipeline is a technique where multiple instructions are executed at different stages at the same time. It's just like a factory assembly line. Each instruction is processed in a steps and these steps overlap that improves performance but it's also introduces hazards. Next we can see the 5 stages of MIPS pipeline. First one is IF, instruction fetch. This can be mainly used to read the instruction from the memory. Second one is ID, instruction decode or register fetch. This can be used to decode the register and read the register value. Third one is execute, EX. Perform the operations like addition, subtraction or calculus addresses. Okay. Fourth one is memory access, MEM. Load data from memory or store data to memory. Okay. Fifth one is write back, WP. Write the result back to the register file. Okay. Next, why hazards occur? Normally, the many of the instruction can be overlap. Sometimes they interface with each other. So interfaces is called a hazard. Because of hazard, instructions next cannot safely execute in the next cycle. So the CPU delay is using a stall or bubble in a pipeline. Next we can see the type of hazards. First one is structural, second one is data, third one is control hazard. First we can see the structural hazard. Structural hazard is a hardware. It means it can be allocated resources. It cannot be executed a same instruction at the same clock cycle. If it can be executed that same instruction or the same clock cycle means it can be make a conflict. So we can see the image instruction 1 and instruction 4 at the time t4 the same of the instruction can be executed that make a conflict of the program and it will be make a error. So we can be solution of the structure hazard can be use a stall. That means we can wait a first instruction until the first instruction will be end. So a second one is will be start. So avoid the problem and also we can be efficient way to avoid this the structural hazard. Second one is data hazard. Data hazard mainly occur when one instruction depend on the result of the previous instruction. That is not ready means it will be occur a data hazard. The solution of the data hazard means forwarding the operand. That means pass result directly from the EX or MEP stages. Okay, or using the stalling inside a delay cycle. Third one is control hazard. Normally, the control hazard occurs when the processor does not know which instruction comes next because of the branch. Normally, branch decision is know only in the EX stage, that means execution stage, but IF and ID stages has already fetched the next instruction. The solution of the control hazard, that means flushing the pipeline, branching prediction, or delay the branch. Here the simple assembly program of check number is a even or odd. First we can see the dot data. This section is essential for the program storage area for fixed value variable and message. The second one is num. It can be the store the integer value you want to check. The third one is even message or message. Store the text string printed to the console. That will be important to of the program. The core of the program logic is dot text section. Contains the instruction that execute the program. And then LWTO num. This the move the number stored in memory into the register TO. Here the TO is the register. Number we can know that we can be already here the consider 7. Okay. And the next line is and I, that is the immediate and this is the core logic. It perform a bitwise and between the number TO and the value of 1. So if the value is 0 means that will be the move to the even label. If the 1 is that move to the odd label. That will be the control flow. Next one is the branch equal BEQ T1 comma is underscore even. The branch equal. The already I told you if the T1 is 0 means so that the number the program jump to the is underscore even label. If the 1 means it will be go to the odd label. So If the E call, this block prepare and execute the system call. It says the register A0 to the message address and A7 to the print service code. The system call interface between the program and the OS simulator. Okay. What are the hazards occur in my program? First, data hazards. That line LWTO 0 S1 at T1 T0 T2. That the place and I depends on the output of LWTO. This is cause a classic load use data hazard. RIPS will show a stall between these instructions. So I will add a stall of the data hazard for the solution. Okay. Second one is control hazard. In my program, control hazard is also occurred. That the line BEQ SOS1 label. The branch decision is also known only in the EX stage, but IF and ID stages have already fetched the next instruction. So if the branch is taken, the next instruction that was already fetched must be flushed. The solution of the control hazard, I will put the flushed attached. So this is the control hazard in occurred in my program. In my program structure hazard. Next, this is my flow of the processor. It can be executed which number is occur. Here the output is even. Thank you.